We're back with another ShopWare Tech Tips video where we're going to be going over programming this part with the new Mastercam Optirough and hybrid toolpaths versus some of the traditional toolpath techniques and some of the benefits that you can gain by using this newer technology. So the first way we have it programmed here, and think of the dynamic Optirough as a 3D rough toolpath that only does 3D motion when it needs to. So it's going to remove as much material in a 2D fashion before it starts to do 3D toolpath motion. So if I backplot this toolpath here, you'll see that it's going to helical down into the part, and then it's basically going to spiral out in a 2D fashion and remove the material. And it's going to alter the toolpath motion similar to our 2D dynamic toolpaths, so it avoids pinching in corners and it maintains that chip load throughout the toolpath. And then what we also have programmed in here is what's called a step up, as like a bullnose end mill I'm using here is more effective on the 3D cuts as it's moving back up and out of the part. So I have my first depth cut, and then I go down in again, and it helicals in and does the rest of the part and step ups throughout those sections. And I did a stock model here just for reference to basically show you what the part looks like after that roughing operation. As you can see, we're already getting pretty close to our net shape there. So I go back and do what's called a hybrid toolpath, and there's a couple settings in here that people may not notice, is that I can include flats, ignore flats, or treat them all the same. And I have this basically set to ignore the flats because I'm using a 1/4-inch ball end mill here to finish a part, but a 1/4-inch ball isn't necessarily effective at finishing flat floors because I have to have a really small step over to ensure that floor is nice and flat. So I have it set to ignore those flats. And you'll also notice here that the step over will change based on the angle of the geometry. So as I get to some of these steeper walls here, it'll add cuts in there so that the finish is maintained that I defined throughout the entire toolpath. And you also notice the tool will minimize the retracts throughout the toolpath. So I go back and I basically copy that operation down, and instead of saying ignore the flats, I say just the flats, and I use a 1/4-inch bullnose end mill. So I have more of a flat surface cutting area, and I can basically go ahead and finish the floors. Now, these are about 100 thou radiuses in these ribs, so they were a bit too big for my original finished tool in the hybrid. So I went back through and just did a pencil HighSpeed toolpath to clean that up. Now, if we select all these toolpaths, I can go to the 3D verify. And if you also notice here, I have my Kurt Weiss assigned, and that's known as a fixture in the software, and we can collision check against that throughout the toolpath. And if you also notice here, my total time here is, I simulated basically kind of a standard VMC you'd be seeing in the market today as far as like a mid-range, a 12,000 RPM Cat 40 type machine. And my total cycle time here is about 31 minutes. And as we'll get to the end here, I basically said fast forward, and so you don't have to sit through and watch all of it, all the material removal. But I do have the color loop turned on, and that's a representation of our finished part here. But I can go to verify compare, and I have a 5 thou tolerance set, and I can turn on the compare, and it looks like we're pretty good here. The ribs are finished, and we should be good. So now if I were to program these using the traditional Mastercam 3D toolpaths, let's take a look at a little bit how that would look. So I have what people know as the surface rough pocket toolpath here. And I'm using a more traditional style of programming where I'm taking, 100 thou step down and 50% of the width of the tool. So I'm only using that tip of the tool to rough out the part. So I get uneven tool wear. I'm not able to run the machine as fast. And it's just basically our old technology. So it goes in there and does, basically an offset tool path. It doesn't necessarily account for sharp corners or where that tool is going to meet full engagement and so forth. And I created a stock model of that just so you can see, and it looks fairly similar to the Optirough toolpath, but you will notice that these scallop heights with my step down are much bigger. And actually, I think I did, because 100 thou was too much for the finish tool, I did 50 thou step overs or step downs for that rough toolpath. And then I go back in and do a surface finish scallop from the older style toolpaths. And while this is pretty nice, I have to maintain that small step over throughout the entire part. So I'm not necessarily maximizing the toolpath based on the geometry of my part. So I'm taking really small step overs on the floor to maintain a smooth finish down there, but I'm also taking probably more cuts than I need to on some of these vertical sections, as you saw how the hybrid varied those step overs based on the geometry angle in the first example. And then I go back and do the same pencil finish toolpath just so we can get basically a completed part. But if I go in here and verify these toolpaths, and I'll skip forward here, but really we're more concerned with the move list here. So I'm running it, around 6,000 RPM, a little faster on the finish toolpath, but my feed rate isn't able to be as high with the newer style toolpaths. And as you can see, I'm at about 1 hour and 50 minutes to finish this mold. Whereas if you remember from the first group of toolpaths, I was only at about 31 minutes. So that's quite a bit of percentage of time savings using the newer modern set of toolpaths to complete this part. And I hope you guys got something out of this video. And let's do the compare here right before I close it up. But any questions, please feel free to contact us. And as always, thanks for watching.